Oh, now it works. Okay, so never mind. But yesterday my recording was not working. It just kept shutting off when I tried to record. So if you were gone yesterday, to get the notes, get them from a friend or let me know. My copy's out right now being copied down, but get the notes somehow. And then any questions you have, please ask, because the recording isn't there for the explanations. But today is different. So not being here yesterday, today, it's not like there's anything you're not going to be able to follow along with. Okay, today and tomorrow, and actually Thursday, we are going through surface area. Today is surface area of prisms, so a rectangular prism, triangular prism, and then tomorrow is surface area of cylinders, I believe. And then on Thursday, because we have shortened classes due to the career fair in the afternoon, it's going to be practice with surface area of both types. So you get kind of an extra half class period to practice on Thursday. Friday, we'll be then going into 12.3, and then that is halfway through chapter 12. So I did write on the board next week, Tuesday, is when the quiz is planned on 12.1 through 12.3. So Monday would be review, quiz on Tuesday. But for surface area prisms, so we have quite a few vocabulary terms to talk about first, dealing with prisms, and then we'll get into what is called the lateral area and then the surface area. So in terms of a prism, first of all, you have to be able to identify the base of a prism or bases. Bases are parallel faces. So that's key. Normally when you look at a figure, a three-dimensional figure, you think of the base as being the bottom. But you will have problems on your assignment for today where the base is actually not the bottom of the shape that you see. The bases have to be parallel faces. So if you're looking at the bottom and the face, it's not parallel to a different face, it's not a base. You can't use that as a base. Then we have lateral faces also, and these are faces that are not bases. So you have your bases, and then every other face, you can think of these as kind of the side faces. If you want to think of it that way, those would be the lateral faces. And I'm going to reference these pictures down here also as we go through this. So if you look, there's two prisms drawn. We'll talk about the difference between right and oblique. But you can see here, they have the bases labeled. So these two hexagons would be the bases, actually for both. And then all of the other faces, those side faces, are the lateral faces. Then we have lateral faces intersect each other at the lateral edges, which are parallel and congruent. So lateral edges are parallel and congruent to each other. And again, that's just where the lateral faces meet the intersections of them. So again, if you look at the picture, here's a lateral edge, kind of not really a corner, but if you think of it that way, where the two faces meet, we have a lateral edge here. And then the lateral faces intersect the base at the base edges. So base edges would basically be all of the sides of the base because those sides are intersecting one of your lateral faces. Then we have the altitude. We've talked about altitude before with triangles. So the altitude is a perpendicular segment. That's key. Has to be perpendicular. That joins the planes of the bases. And then, therefore, the height of a prism is the length of the altitude. So when we talk about height, that's going to be key. Also, we talked about height with all of our area formulas in chapter 11. The height has to be the length of the altitude, meaning it has to be a perpendicular segment. If it's not perpendicular, it's not the height. So the key here is you don't want to, I guess, mistake a lateral edge for an altitude. So here in this right prism, this lateral edge actually is an altitude because of that 90-degree angle. But over here, this lateral edge is not an altitude. The altitude would be this distance here. So it's not actually part of the shape itself, but it's that perpendicular distance from one base to the other. So you have to look for that 90-degree angle for the altitude and the height. And then a prism, so just the definition of a prism. It's a polyhedron with two parallel congruent bases. A polyhedron, by the way, is a solid figure that has multiple plane faces. So poly meaning the many or the multiple. So then the difference between a right prism and an oblique prism, a right prism has lateral edges that are altitudes, and the lateral faces are all rectangles. Versus an oblique prism has lateral edges that are not perpendicular to the bases. And therefore, at least one of the lateral faces is not a rectangle. So you can see in that right prism, each lateral edge would be perpendicular. There's that 90-degree angle. Therefore, all of your lateral faces are rectangles. Here, the lateral edge was not an altitude. The altitude is out here. So some of your lateral faces might be rectangles. Others might be parallelograms, but they're not all rectangles. And these are what we're working with today, our prisms. So now we're getting into how to calculate lateral area, and then this is all leading up to how to calculate the surface area. So lateral area is the sum of the areas of the lateral faces. So hopefully that makes sense. It's adding together all of the areas of your lateral faces is the lateral area. And then this is kind of separate, but it's explaining what's down here. So down here, it's showing the net for a triangular prism. So to explain what the net is, that's what goes here. The net for an object is a pattern to make the solid. And I'm only defining that because it's referencing the net here. So here's a triangular prism. It's called a triangular prism because the two bases are triangles. And then you have three rectangular lateral faces. So this is the net for it. So here you have your three rectangular lateral faces. It's kind of like if you take it apart and lay it flat. And then these are the two triangular bases. So it's if you kind of disassembled this and laid it out flat. That's what it would look like. So the lateral area is the shaded part here, which notice the lateral area is just one long rectangle. And the length of that long rectangle would be A plus B plus C. And you have the width of that rectangle is H, or that's the height of the rectangle. So area of the rectangle is length times width, or base times height. So the area of that shaded region would be your quantity A plus B plus C times your height. Now that's not the formula for lateral area always, but to help explain this, this A plus B plus C, notice if I take, I'll draw this one here. So if I'm just outlining this bottom base, which is this triangle, the A plus B plus C is the perimeter of that triangle. It's the perimeter of the base. So therefore, the lateral area this is the perimeter of the base times the height of the figure, or height of the prism. So P, this is the formula for lateral area, capital P times H. Capital P is the perimeter of a base. And then H is the height of the prism. So if you want to draw an arrow, this A plus B plus C is actually the perimeter of that base. And then the height of the prism is the H. So the P, capital P times H is what you need to remember for lateral area. Okay, questions there. So whenever because I reference this a lot in all of the classes I teach, but when you have formulas, because I know we always think, okay, we have to memorize this formula. If you understand the formula, it really helps you then to memorize it. So if you don't understand why the formula is what it is, it's harder to memorize. So if you understand, again, that if you take the net, you're making a big rectangle, so it's the perimeter of the base ends up being that length and then your height. Just seeing where that comes from may help you then remember how to get that lateral area. But we'll move on then to surface area, because that's really what we're trying to get at with this lesson. Surface area is the sum of the lateral area and the areas of the bases. So surface area, just think it's the area of the entire surface of your figure. So you have to add together the area of every single surface, meaning the lateral area is the surface of all of your sides. And then you have two bases, top and bottom, and you want to add those areas together also. So there's two ways you can write the formula for surface area. So one way is S equals L plus 2B. So L is the lateral area plus you have two bases. So B, capital B here, is representing the area of a base of the prism. So lateral area plus the area of your two bases added together. The other form of writing the formula, the capital P times H plus 2 times capital B, capital P times H is your lateral area. That's what we just talked about. So it's just putting that formula in place of the L. But they're the same thing. So again, P here is the perimeter of a base. And then H is the height of the prism. Okay, so we have two examples here. It says for each of these to name the prism. So what is the prism called? And then find the lateral area and the surface area. And I'll show you when we go through these how I kind of organize my work with them. And what I'd be looking for you to show, so when you have your quiz on Tuesday, as these are graded, in case you're not getting the right answers, what I would need to be able to see to figure out how you got your answers. So if we look at example 1, this would be a rectangular prism. Oops, if I could spell here. And that is because the bases are rectangles. And unless otherwise stated, you are okay to assume that the prisms you have are right prisms. If it is not a right prism, the problem will tell you that. So even though there's not 90-degree angles drawn in here, I can assume that it's a right prism, so this is a 90-degree angle. I can assume here this would be a 90-degree angle. So I'm letting you know that now it's okay to assume that. The problem will tell you if it's not. It'll tell you if it's not a right prism. I think on your assignment, though, the right angles are already drawn in, so you don't even have to guess or make an assumption, because I know normally you're told not to assume that. So if we find the lateral area first, in order to find the lateral area, we need to know the perimeter of a base, and we need to know the height. So I'm going to show here, I'll put capital P equals. So here I can use this. I'm going to highlight my base. I can use this as my base. So that rectangle that has a length of 9 feet and a width of 4 feet. So I know that I have 2 lengths, they're both 9, and then 2 widths, they're both 4. So my perimeter would be 2 times 9 plus 2 times 4. So that would be 26 feet. So that's the perimeter of a base. And then also for lateral area, I need to know the height of the prism. And the height of the prism is this 6. So how tall it is. So 6 feet is my height. Okay, so lateral area, I take perimeter of the base, multiply it by the height. So I have 26 times 6, meaning my lateral area is 156, and that would be in feet squared. Okay, and this is the work that would be helpful for me and helpful for you if you're getting answers wrong in order to get partial credit. Helpful for me to see when I'm grading that I can see that you found the perimeter of the base, what it was, that you found the height, what it was, and that you're multiplying them to get the lateral area. Otherwise, if I just have to guess how you got your answer, and I may not know, you might just lose all the points there. Then to find the surface area, so surface area is my lateral area plus 2 times the area of a base. So I need to find what the area of a base is. That would be the area of the rectangle that I highlighted. Area is length times width, so it would be 9 times 4. So that's 36 feet squared is the area of one base. So then for my surface area, I would take my lateral area of 156 and add to it 2 times the area of the base. So 2 times 36. So 156 plus 2 times 36 is 228 feet squared. And again, hopefully that formula makes sense. The 156 is the area of, in this case, the 4 sides. And then the 2 times 36 is the area of your 2 bases that are congruent. So you're adding both of those areas together. Any questions on that one? Okay, so if you look at 2, in terms of what this prism would be called, what do you think? Triangular prism, because here, okay, here's what I was talking about with bases. The base, or both bases, are the triangles. The base is not this rectangle that's actually on the bottom. The 2 triangles are the 2 bases. So this is a triangular prism. And again, it might help, like I'm doing right now, to highlight one of your bases so that when you're finding the perimeter of a base and the area of a base, you've highlighted what shape that is. You might not need to. It's just, if it helps, you could do that. So I need the perimeter of a base, meaning the perimeter of this triangle. I'm going to write this down here. I don't really have a ton of room. So perimeter is, so I have these 2 sides of my triangle are both 12. How would I find this 3rd side? It's the hypotenuse, yep. So how do I find it? Pythagorean theorem. So to find this side, I can do 12 squared plus 12 squared equals, and I'll just call that x squared for right now. So that is 144 plus 144, so 288 is x squared, square root. So I am going to round my final answers to 1 decimal place. So this one I'm actually going to round to 2. I'm going to do 16.97 or keep it right now as 16.97. So that would be this side is 16.97. So then my perimeter of my base would be those three sides added together. So 12 plus 12 plus 16.97. And that would be 40.97 for the perimeter. That's in millimeters. And then also for lateral area, I need the height of the prism. So what would the height be? The height would not be 12. Because remember, this is your base. It's the 8. Yes, this is your height then. So you have to picture if the triangle, if you flipped it so the triangle was on the bottom, this 8 would be how tall it is. So the 8 is your height. So the 12 would be the height of the triangle. The 8 is the height of the prism itself. So then I would multiply 40.97, the perimeter, times 8. And like I said, this one, my final answers for lateral and surface area, I'll round to 1 decimal place, so 327.8 approximately. And that would be millimeters squared. And then surface area, I have my lateral area plus, I need 2 times the area of a base. So I need to know what the area of a base is. And again, the base is this triangle. So how do you find the area of a triangle? Base times height divided by 2. So for the triangle, the base is 12 and the height is 12. So it's 12 times 12 divided by 2. So 144 divided by 2, the area of one base would be 72. So my surface area is my lateral area, 327.8, plus 2 times the area of the base, so 2 times 72. And that would be 471.8 millimeters squared. Okay, questions there? So, like I said, this is what you have to watch out for when a shape or when a figure looks like this on your paper. Making sure you know what the base is and then what the height is. Those are easy to get mixed up. So take your time with it, don't rush through it.